Right now, you're lying somewhere on the surface of a rock, and that rock is falling around a star at 30 kilometers every second. You cannot feel it. Nothing in the room is moving. And yet, since you began listening to this sentence, you have traveled several hundred kilometers through space, and you will never pass through that place again. Tonight, we're going to leave. Slowly, gently, we're going to pull away from where you are lying and travel outward, past the moon, past the sun, past the last planet, out of the solar system entirely, out of the galaxy, until we reach the edge of everything that can be seen. There is no hurry. It takes the universe billions of years to do anything at all. So settle in, close your eyes if you like, and let us find out exactly where you are. We begin here. A planet 7/10 covered in liquid water, wrapped in a skin of air so thin that if the Earth were the size of an apple, the atmosphere would be thinner than the apple's skin. Above you, that air fades gradually into nothing. There's no line, no wall, no moment where the sky ends. It simply gets thinner and thinner until, somewhere around 100 kilometers up, there's so little left that we agree to call it space. You could drive there in an hour if a road went straight up. That is how close the edge of the world is. Everything that has ever lived, every forest, every ocean, every person has spent its entire existence inside that thin blue film. Keep rising. The curve of the horizon closes into a circle. The circle shrinks into a sphere, and now the whole planet is beneath you, turning slowly, entirely silent. 400,000 kilometers out we pass the moon, a dead, gray world locked in a slow embrace with ours, always showing us the same face. Light from Earth takes about 1 1/3 seconds to reach it. It is the only other place human feet have ever touched, and the footprints left there in the dust have no wind to erase them. They will still be there, sharp-edged, in 1,000,000 years. From Moon, the Earth is the size of a marble held at arm's length, and it is already, unmistakably, the only interesting thing in the sky. Now the moon falls away too, and we turn toward the light. The sun is 150 million kilometers from where you are lying. Its light, the light that warms your window in the morning, that grew every plant you have ever eaten, takes 8 minutes and 20 seconds to make that crossing. When you look at the sun, you're not seeing it as it is. You are seeing it as it was 8 minutes ago. If it vanished this instant, you would have 8 more minutes of ordinary daylight before anyone on Earth knew. It is a perfectly average star, a ball of hydrogen so vast that 1,000,000 Earths would fit inside it, converting 4 million tons of itself into pure light every second. It has been doing this for 4.5 billion years, and it has enough fuel for about 5 billion more. Pull back further, and the planets come into view, but not the way they look in a diagram. The truth about the solar system is that it is almost entirely empty. If you shrank the sun to the size of a beach ball, Earth would be a peppercorn about 30 meters away, and Neptune would be another peppercorn nearly a kilometer distant. Everything else in between, the whole vast neighborhood, is nothing. Cold, quiet, enormous nothing. We are so used to seeing the planets crowded together on a page that the real scale is almost impossible to hold in the mind. Space is not mostly stars and planets. Space is mostly space. Out past the asteroids, we cross into the realm of the giants. Jupiter, a world so large that all the other planets could fit inside it with room left over, with a storm at its equator that has been turning for centuries. Then Saturn, wrapped in rings of ice, so wide they would nearly span the distance from Earth to the moon, and so thin that in places they are only meters thick. Then the ice giants, Uranus, tipped on its side, Neptune blue and howling with the fastest winds in the solar system. Sunlight out here is 900 times fainter than it is on your windowsill. Noon on Neptune looks like deep twilight, And from here, the sun is no longer a disk at all. It is just the brightest star in a very dark sky. Beyond Neptune, the solar system does not end. It simply thins out. We pass through the Kuiper Belt, a wide ring of frozen worlds and comets, and then into a region so empty and so vast that a spacecraft crossing it sees nothing for decades. Out here, 24 billion kilometers from your room, is Voyager 1, the farthest object our species has ever thrown. Its radio whisper takes almost a full day to reach us. And even Voyager, after nearly 50 years of flying, has barely left the doorstep. Ahead of it lies the Oort cloud, a shell of sleeping comets that may extend a light year or more in every direction. Voyager will take another 300 years just to reach its inner edge and 30,000 years to pass through it. Now, the distances stop being measured in kilometers because kilometers have become useless. From here on, we measure in light years. The distance light travels in a year, about 9.5 trillion kilometers. The nearest star to the Sun is Proxima Centauri, 4.25 light years away. That is the next house on our street. And it is so far that the fastest spacecraft ever built would need more than 70,000 years to arrive. The light landing on your window from that star tonight left it when you were 4 years younger. And this is the ordinary condition of the universe. Stars are not neighbors. They are islands separated by oceans of dark, each one alone with its own small family of worlds. Between those islands, the darkness is not truly empty. It is filled with thin, cold clouds of hydrogen and dust, the raw material of everything. Where those clouds grow dense enough, gravity takes hold, and they begin to collapse. In their hearts, pressure builds until hydrogen ignites and a new star switches on. Around it, the leftover debris flattens into a disk, and in that disk, dust grains stick together into pebbles. Pebbles into boulders, boulders into worlds. This is where you came from. Every atom in your body heavier than hydrogen was cooked inside a star and scattered when that star died, drifting for billions of years through clouds like these before gravity gathered it into the rock you are lying on tonight. Pull back far enough, and the individual stars blur together into something with a shape. You live inside a galaxy, a flattened spiral of roughly 200 billion stars, 100,000 light years from edge to edge. Our sun is nowhere near the center. It sits about 26,000 light years out, in a quiet suburb between two of the spiral arms, and it is carrying us around a galactic center at more than 200 kilometers per second. Even at that speed, one lap takes about 230 million years. The last time the sun was in this position on its orbit, the first dinosaurs were appearing on Earth. The sun has made this journey perhaps 20 times since it was born. At the center of it all, hidden behind thick lanes of dust, is a black hole 4 million times the mass of the sun. It is not devouring the galaxy. It is simply the still point that everything else turns around. And wrapped around the whole spinning disk is the halo, a vast, faint sphere of the oldest stars, drifting on long, lonely orbits. These are the survivors of the galaxy's violent childhood, and among them are globular clusters, dense knots of hundreds of thousands of ancient stars, packed so closely that a planet inside one would have a night sky with thousands of stars bright enough to read by. Now leave the galaxy entirely, rise above the disk, and watch it shrink until the whole thing, every star you have ever seen with your naked eye, every constellation, every story anyone has ever told about the night sky, becomes a single faint pinwheel of light. 2.5 million light years away hangs another one, Andromeda, larger than ours, and coming straight for us at about 110 kilometers per second. In roughly 4.5 billion years, the two galaxies will meet, pass through each other, and merge. Almost no stars will collide. The distances between them are far too great. Instead, the gas clouds will crash and ignite, and the two spirals will slowly settle into one enormous ball of stars. Andromeda and the Milky Way are not alone. Together with about 50 smaller galaxies, they form the local group, a little family bound by gravity. And the local group is one small member of something far larger. 65 million light-years away lies the Virgo cluster, more than 1,000 galaxies swarming together. And Virgo itself is only the dense heart of something bigger still. A supercluster 500 million light-years across, a great network of galaxies flowing together like water finding a valley. At this scale, galaxies are no longer objects. They are points of light. They are dust. Pulled back further, and the structure of the universe finally reveals itself. Galaxies are not scattered at random. Over hundreds of millions of light years, they arrange themselves into filaments, long, luminous threads of thousands of galaxies, wrapped around enormous voids where there is almost nothing at all. It looks at the very largest scale like a web, or a nervous system, or the pattern of foam on the surface of a wave. In 1995, astronomers pointed Hubble at a patch of sky that appeared completely empty, a piece of darkness about the size of a grain of sand held at arm's length, and let it stare for 10 days. That empty patch turned out to contain about 3,000 galaxies. Not stars, galaxies, every one of them holding 100 billion suns. And now we reach the edge, though it is not the kind of edge you can touch. Light travels fast, but not infinitely fast, and the universe has only existed for 13.8 billion years. So there's a limit to how far we can see. The distance light has had time to cross since the beginning. Look far enough in any direction, and eventually you're looking so far back in time that you reach the moment the universe first became transparent, about 380,000 years after it began. That is what we find at the edge in every direction. Not a wall, but a wall of light. The cooled afterglow of the Big Bang itself, arriving now from everywhere as a faint hum of microwaves. It is the oldest thing there is, and it is falling on your roof tonight. So here is your address, as best we can write it. You are on the third planet of an average star, in a quiet arm of a spiral galaxy of 200 billion suns, in a small group of galaxies, at the edge of a supercluster, somewhere in a web of perhaps 2 trillion galaxies, inside a sphere of observable universe about 93 billion light-years across. And beyond that sphere, almost certainly, it simply keeps going. We're just out of time to see it. That is where you are. And the strangest part of all of it is this. For nearly 14 billion years, this universe expanded and cooled and forged its elements and built its galaxies in complete silence, with no one to see any of it. And then, on one small wet rock, some of that ancient scattered stardust arranged itself into something that could look up and measure and understand where it was. You are the universe, briefly awake, wondering about itself. And in a moment, you're going to fall asleep, which is also, in its way, one of the most remarkable things atoms have ever learned to do. Sleep well. Everything out there will still be turning when you wake. This has been the Silent Cosmos, and there are more quiet journeys waiting for you on the channel.